Welcome to First Grade Tutors Maths channel. If you're a student who is interested in learning mathematics, you are at the right place. Today's lesson will focus on number-based system, and this is just lesson 1. We will still continue this topic in another video. So, a number to base A is composed of integers from 0 to A minus 1. For example, a number to base 8 is composed of the integers 0, 1, 2, 3, 4, 5, 6, 7. And a number to base 4 is composed of the integers 0, 1, 2, 3. So also, a number to base 2 is composed of 0 and 1. In this lesson, you will learn expanded notation and conversion from other bases to base 10. Now let's look at expanded notation. See the example on the screen. You see that this number 50,622 is equivalent to 5 times 10,000 plus 0 times 1,000 plus 6 times 100 plus 2 times 10 plus 2 times 1. And then you see that it's equal to 5 times 10 raised to power 4 plus 0 times 10 raised to power 3 plus 6 times 10 raised to power 2 plus 2 times 10 raised to power 1 plus 2 times 10 raised to power 0. Now this is how to express 50,622 in expanded notation form. You can see example 2. To express 6,045.632 in expanded notation form, we have 6 times 1,000 plus 0 times 100 plus 4 times 10 plus 5 times 1 plus 6 times 1 over 10 plus 3 times 1 over 100 plus 2 times 1 over 1,000. And then finally, we have 6 times 10 raised to power 3 plus 0 times 10 raised to power 2 plus 4 times 10 raised to power 1 plus 5 times 10 raised to power 0 plus 6 times 10 raised to power minus 1 plus 3 times 10 raised to power minus 2 plus 2 times 10 raised to power minus 3. So you can see how we expressed 6,045.632 in expanded notation form. Let's move to example 3. So we have 0.0467 to be expressed in expanded notation form. And as you can see, we first of all broke it down to 0 times 1 plus 0 times 1 over 10 plus 4 times 1 over 100 plus 6 times 1 over 1,000 plus 7 times 1 over 10,000. And then finally, we express 0.0467 in expanded notation form as 0 times 10 raised to power 0 plus 0 times 10 raised to power minus 1 plus 4 times 10 raised to power minus 2 plus 6 times 10 raised to power minus 3 plus 7 times 10 raised to power minus 4. Now let's move on to conversion from other bases to base 10. To convert from other bases to base 10, you replace 10 with the base number you are converting from in the expanded notation form. Now let's see the following examples. The next example says convert 546 from base 7 to base 10. So you can see on the screen that instead of multiplying the integers by 10 raised to power 2, 10 raised to power 1, and so on, like the expanded notation form, we used 7 raised to power 2, 7 raised to power 1, 7 raised to power 0, because we are converting from base 7 to base 10. To convert 546 from base 7 to base 10, we have 5 times 7 raised to power 2 plus 4 times 7 raised to power 1 plus 6 times 7 raised to power 0. And then that is equal to 5 times 49 plus 4 times 7 plus 6 times 1. And then we have 245 plus 28 plus 6, which gave us 279 to base 10. We have another example here which says convert 1 EB from base 16 to base 10. Remember that a number to base A is composed of integers from 0 to A minus 1. So this means that a number to base 16 is composed of integers from 0 to 15. It is important to note that letters are used to represent the double-digit integers that are present in base 16, such as 10, 11, 12, 13, 14, and 15. A represents 10, B represents 11, C represents 12, and so on. Therefore, B and E in the question represent 11 and 14 respectively. Now, it doesn't just apply to this question. These letters generally represent these numbers. So to convert 1EB from base 16 to base 10, we have 1 times 16 raised to power 2 plus E times 16 raised to power 1 plus B times 16 raised to power 0. And then we have 256 plus 14 because E is equal to 14. So we have 256 plus 14 times 16 raised to power 1. And B is equal to 11, so we have 11 times 16 raised to power 0, and then we have 256 plus 224 plus 11, and finally we have 491 to base 10 as our answer. Please, there are some things we need to take note of. Base 2 is the same as binary. Base 8 is the same as octal. Base 10 is the same as decimal or denary. Also, base 12 is duodecimal and base 16 is hexadecimal. So we have example 6, and example 6 says express 11110 base 2 as denary. Now we know that denary means base 10, so we are converting from base 2 to base 10. And so we have 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 0 times 2 raised to power 0, and then we have 16 plus 8 plus 4 plus 2 plus 0, and then our final answer is 30 to base 10. The next thing we'll be looking at is conversion of fractions in other bases to base 10. In base 10, 0.1 is equal to 1 over 10, and 0.2 is equal to 2 over 10. So also in base 4, 0.1 is equal to 1 over 4, and 0.2 is equal to 2 over 4. In base 8, 0.5 is equal to 5 over 8, or 5 times 8 raised to power minus 1. So consequently, 0.233 to base 4 can be expressed as 2 times 4 raised to power minus 1 plus 3 times 4 raised to power minus 2 plus 3 times 4 raised to power minus 3. This is the principle that is used in converting fractions from other bases to base 10. Now let's look at the following example. Express the following fractions as decimals, and we have A, B, and C. We know that decimal means base 10, so we are converting them to base 10. So to convert 31.21 base 4 to base 10, we have 3 times 4 raised to power 1 plus 1 times 4 raised to power 0 plus 2 times 4 raised to power minus 1 plus 1 times 4 raised to power minus 2. And then we have 12 plus 1 plus 2 times 1 over 4 plus 1 times 1 over 4 raised to power 2. And then it goes on, and then we see on the screen that we have our final answer as 13 whole number 9 over 16 to base 10. Take a look at example 7b. It says convert 38.1e from base 16 to base 10. Now remember that letters generally represent the double-digit integers, just like the previous example. So that is also applicable here in this question. Noun. To convert 38.1e from base 16 to base 10, we have 3 times 16 raised to power 1 plus 8 times 16 raised to power 0 plus 1 times 16 raised to power minus 1 plus e times 16 raised to power minus 2. And then we have 48 plus 10 times 1 plus 1 times 1 over 16 raised to power 1 plus 14 times 1 over 16 raised to power 2. And then we have 48 plus 10 plus 1 over 16 plus 14 over 256. And it goes on and on as it is on the screen. And then finally we have 58 whole number 15 over 128 to base 10 as our answer. Let's move to example 7c. We need to convert 10.1111 base 2 to base 10. So we have 1 times 2 raised to power 1 plus 0 times 2 raised to power 0 plus 1 times 2 raised to power minus 1 plus 1 times 2 raised to power minus 2 plus 1 times 2 raised to power minus 3 plus 1 times 2 raised to power minus 4. And that is equal to 1 times 2 plus 0 plus 1 times 1 over 2 plus 1 times 1 over 2 raised to power 2 plus 1 times 1 over 2 raised to power 3 plus 1 times 1 over 2 raised to power 4. And so we have 2 plus 0 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16. And then we have 2 whole number 15 over 16 to base 10 as our answer. So we've come to the end of this lesson. I hope you learned something today. See you in the next lesson. Bye.